Hello again, and welcome back to Operations Management. We're continuing with our talk on inventory. In our last session, we did the total annual cost equation, and in this one, we're going to be looking at EOQ, the economic order quantity. If you recall from our last session, we had that total cost equation, and that referred to cost over a year. EOQ is going to minimize that cost. So we're going to take that total annual cost and we're going to try and find a way to make it the smallest amount over a year. EOQ is the starting point for inventory analysis. We use certain assumptions. They are not very realistic, but they are a way to give us a starting point. So those assumptions include that the demand is known, it's constant, which means we never have fluctuations. We know exactly how much we are going to be using at any given time. The lead time is known and constant, which means from the time we place an order to the time we get it, we know exactly how long it's going to take, and that never changes either. And when we get the inventory, we get it all at once. We never get partial orders. There's never any problems with it. So these are key assumptions with the EOQ equation. Admittedly, they're not very realistic, but it is a starting point for analyzing inventory. So when we look at the EOQ model, you notice that it's a sawtooth. If you take a look right up here, we have the order quantity, Q. When we place an order, this is the amount that we're ordering, and that over time, because our demand rate is constant, it has a slope down. So looking at that second arrow, you can see how it's a very smooth line going from the top point down to 0, which means our average inventory is going to be Q over 2. We've taken the highest amount, which is the amount we order, which is Q. Our lowest amount is 0, and we average the two of them, and that's how we get Q over 2. Now when we take a look at the total cost equation, we notice a couple of things. One is the setup cost, which is the ordering cost, is a curved line, starting very high, and it flattens out and it gets lower and lower. That's because we're spreading the cost of ordering depending on how many items we are ordering at once. If we're only going to order 5 times a year, it's going to cost more than if we order 3 times a year or 1 time a year. So the more times we order, the costs go up. So if there's more in the order, we don't have to order as many times. So that's how that curve goes down. The second line, the holding cost, well, the more we hold on to at any given time, our cost is going to increase. That's why that one is heading upwards. We bring the two of those together along with the cost of the product itself, and we have a total cost. And that is another curve there, bringing the two together. Now, something interesting happens is you notice that the lowest point of that total cost curve is at the same point where the ordering cost is equal to the holding cost. So when that happens, we can actually calculate a value for Q to find out what that quantity is to minimize the total cost. All we have to do is set the ordering cost equal to the holding cost. And that's what we're doing here. We take our setup costs, which is our ordering costs, we set it equal to our annual holding cost, and we just do some basic algebra to determine the quantity. And we end up with our quantity equaling the square root of 2 times R, which is our annual demand, our annual throughput rate, times S, which is the setup cost, divided by our holding cost. We use an asterisk next to Q to indicate that we got this value by using the economic order quantity calculation. So what does this really mean? Let's do a quick example and you'll see. Let's say we purchase batteries from a supplier for a unit cost of $10 and you make smoke detectors. On average, we're going to use 54,400 batteries each year. And every time we place an order, we have a big ordering cost of $1,000. Whether we order one battery or whether we order 100 batteries or 2,000 batteries, it's still going to be $1,000 every time we place an order. Our cost of capital is 10% per year, and our cost of holding is 7% of the unit cost per year. So now, how many batteries should we purchase at a time? So in other words, what is our quantity when we place that order? Then also, what is our total annual ordering cost, holding cost, and our total cost? Let's step through this. Here are key variables. C, the cost per unit is $10. R, our annual demand or our annual throughput rate is 54,400. S, our setup cost every time we place that order is $1,000. And we need H, which is the overall holding cost. So we're going to take our physical holding cost and our cost of capital and multiply it by a cost per unit, and we get a capital H equaling $1.7. Now let's plug that into the EOQ equation. There it is. We put everything in and we have the square root of 2RS over H, and we come up with 8,000. We should order 8,000 batteries at a time. So what is our total setup cost? S times R over Q, $6,800. Our total holding costs, $6,800 as well, which should not be a surprise because we calculated the minimum cost at the point where the holding cost was equal to the setup cost. So those two numbers should be the same when we're using the economic order quantity. Now lastly, our total annual cost says we're going to take our setup costs, our holding costs, and our unit costs and add them all together. And we end up with $557,600. So that's how we use economic order quantity. Key things to remember are, first of all, it's an idealized situation. We know everything: demand, lead time. We never get partial orders. And when we calculate the EOQ, our annual setup cost will equal our annual holding costs. Now we're going to make some changes to this equation in our next session. I'll see you then.